Welcome back to our series of training videos on the Leica SP5 confocal microscope. Now we're going to look at some actual live images generated by the microscope of a cross-section of corn. You'll see this on the monitors as we continue. In this case, we have selected Fitzy Tritzy from our pull-down menu, which activates the proper lasers with the proper amount of power. It turns on the photomultiplier tubes. Here you can see the first photomultiplier tube engaged with a gray line that shows it's turned on, and the second photomultiplier tube. Each one is set to receive information from the emission spectra generated here on the screen. If we go to live, we now see on the right screen the images of our corn in two different colors. We're exciting at two different wavelengths, and we're recording emission information also in two different wavelengths. Now you'll see that we have two screens divided by a square. We can click on one square or another square, and it'll allow us to work on that particular image. If we choose to work on the first image, we need to see that the light is not evenly illuminated and it's not as bright as we would like. At this point, we want to increase our smart gain using our toolbar, which is on the desktop. So we dial the smart gain up, and as you can see, the image becomes brighter and brighter. Rule of thumb is to have the smart gain somewhere between maybe 895 and 920 volts. That gives us a pretty decent image at that wavelength. We double click on this screen again. Now we can click on the right screen and control the smart gain for this image as well. Once again, we're looking for a smart gain of about 900 volts. And so you see here, I'm raising the voltage to about 900. And if we look at the right screen, we'll see that the image is a little bit washed out. It's a little bright. Since I'm at 900 volts on my smart gain, this tells me that my laser power can be lowered. And so if we go over to the left screen, we can lower the power of the 543 laser by diminishing the power applied to the laser. You can see that this now returns a better image that's not as washed out as before. The other tool that's important on the toolbar in getting a good image is the smart offset. The offset should always be a negative number. Usually -2, -3, somewhere in that range. What we're essentially doing is we're controlling the sensitivity of the photomultiplier tube with these two controls. The photomultiplier tube is recording and counting photons that are coming off the image. Again, I want to keep my laser power low and increase the gain and offset of my photomultiplier tube so that I reduce the photo bleaching that takes place in my image and I reduce the amount of wear and tear on the laser. So a good rule of thumb is 900 on the smart gain and a negative number of 3 to 4 or 5 on the smart offset. Once again, I will double click on my image, and again I can see my two captured images and my composite image, which is generated by the computer. I also have another photomultiplier tube that can be used for transmitted light. So I'm going to press stop the live imaging, and now I'm going to select the photomultiplier tube for a bright field image. Again, I go back to live. I'm now collecting 3 different images, but the bright field image you can see is very dark. Let's double click on that, and my smart gain is very low. So I'm going to increase my smart gain until I start to see my transmitted light image. I can also control the offset so that I get good contrast. Now I have a combination of 3 images, including 2 fluorescent images and a bright field image that are output to my screen. So to look at my live image, I'm going to click on the Live tab, and once I click on it, I can see that I have a live image on the screen. At this point, I can control my smart gain and my offset and make sure that my image is well balanced. If I want to capture an image, then I press stop, turning off the live image, and then I come over here and I press capture image, and this will now capture an image with each one of the photomultiplier tubes that have been turned on. Here you can see my PMT1 image, my PMT2 image, my PMT3, which is my transmitted light bright field, and my composite image. These are now stored images in the digitizer. However, they're only stored in RAM. If I want to capture this one image and put it under my experiment folder, I have to right-click on the image and I select Snapshot. Snapshot will take this one picture and put it over in my experiments folder. So if we go over to the experiments folder, I'll click on the tab here, and now you can see this image right here is the one that we just captured. However, this is still in RAM. This information has not yet been saved to my user file. If I want to save this information permanently, I go down to Save All, and my screen comes up. I select Computer, D Drive, Users, and then I select the folder that I want to save my images to, and I click on Save. Then my information, my pictures, all of my experiment information is saved into my folder. So don't forget to save regularly under your Experiments tab in order to keep the system from crashing. We now have a live image on the screen, and I want to show you an easy way to set the gain and the offset so that your images are the crispest they can be. If you click on this little box here, this is the quick lookup table. You click on it once, it changes the color of your pixels to blues and greens that you can use to identify how your gain and offset should be set. Your gain control will change the number of blue pixels in your image. And you want to turn the gain down until you have only a few blue pixels. As you can see here, at about 891, I'm starting to see a few blue pixels in my image. That's the proper setting for my gain. For offset, I want to have as few green pixels as possible just before it goes completely dark. So I adjust my offset until I have just a few green pixels. And you can see there, that's the proper setting for my offset. And so by using the lookup table and the blue and green pixels, I can quickly decide where my smart gain and my offsets should be. If I click on the lookup table again, it goes to a monochromatic image. If I click on it again, it goes to color. Now I can change the color of the output on my screen. To do that, I'm going to stop the live imaging, and then we're going to click on the photomultiplier tube. So I'll go to Stop, turn off the live imaging, and now if I click on this color band on PMT1, I can select the particular color that I'm interested in. I already have green. Let's select blue. And I click OK. And now as you can see, the color here has changed. And so my output for this screen, if I click on live, will be blue. Now you can see that it's a blue image. And I can increase the brightness by either controlling the gain, or I can widen the photomultiplier tube or increase the laser power. Now if I want to change the color output on the red, I go to Stop, I click on the red, and let's make this one glow dark. Click OK. Now if I click on live, you can see that I have a completely different image, and I can control this again with my smart gain and my offset. Now you can see that my composite image is a lot different. So by changing the colors of the output of my photomultiplier tube, I can accentuate regions of interest on my image that I want to show in different colors. Let's collect a live image on our screen. And as you can see, I have a fairly well illuminated image, but it's a little bit grainy. How can I improve the quality of my image? There are several ways to improve the quality of my image. One is to use line averaging, the other is to use frame averaging, and finally I can increase my resolution as well. So we'll click Stop, and we're going to come over to the left screen, and we're going to select the pull-down menu for line average. Let's do 6 line averages. So what are we actually doing? When I select 6, I'm telling the system to read each line 6 times and then make a final output image. So if I click on Capture Image now, I'm telling the system to gather an image, and it's going to take 6 scans per line. Now you can see that was a little slower than capturing an image with 1 scan per line. So let's switch back to 1. We'll do Capture Image. You see how fast the image is collected, but it's a grainy image, low resolution. So if I select, again, 6 line averages, I've told the system to capture me an image, but average out those lines, and you can see a lot of that background noise goes away. I get a nice high resolution image using line average. It does slow it down, so you have to keep that in mind when you're using a fluorophore that might bleach quickly. The more scans you do per line and per frame, the slower your image will be. Let's go back to line average and change that back to 1. And now we'll try a frame average. You can also average the number of frames that you take per picture. So we'll do 4 frame averages. And if I click on Capture Image, I've told the system to take an image but do 4 different frames, and you can see that took a little bit longer, and it is somewhat clearer, but line average tends to work a little bit better for sharpening up your image than does frame average. Another feature that's useful on the left screen next to line and frame average is the Accumulate tab. Accumulate takes an accumulation of each scan. If you have a low signal image and you want to boost the brightness of that image, so here I'll select 4, and now I've told the system to do 4 line scans per line and to accumulate or add together all of those values. Now if I click on Capture Image, you'll see my image brighten up significantly because it's accumulating each one of those scans together. Accumulation is useful, but it also does introduce some noise. You can see that it's still accumulating. The image is still being captured. And maybe if your eyes are sharp enough, you can watch the refresh scan go down through the image, and now it's done capturing the image. And so that's a lot brighter than when I had 1 accumulation, which we'll do again. Fast capture of an image, but low light level. So accumulation increases the brightness of your image, but it does it at the expense of adding noise. Up till now, we've been capturing images at a digitizer resolution of 512 pixels across by 512 pixels down. Let's increase our resolution and give us a better image. So we'll select from the pull-down menu a resolution of 1024 by 1024. If I click on Capture Image, you'll see my image collected on the right screen, a little bit higher resolution than before. And bear in mind that the speed slows down as my resolution increases. If I go to a resolution of 2K by 2K and I capture image, now you see it's slower still. And so this can have an impact on your fluorophore if you're hitting it with too much energy. Another thing that you'll notice is that the amount of noise increases as my resolution increases. Again, to eliminate the noise, I would use line average or frame average. So let's select a line average of 4, and we'll reshoot our image, averaging each line with 4 scans. Now you can see it's significantly slower, but look at how I've eliminated a lot of the noise from my image. So I'm getting a high resolution image, 2K by 2K, with a minimum amount of noise. You notice when we increase the resolution of the digitizer to 2K by 2K, the speed of our scan was slower. particularly when we use line average to average out all the noise. In order to increase the speed of the capturing of the image, we can increase the speed of the processor. So we've been at 400 Hertz. Let's go to 700 Hertz and we'll capture an image again, and we'll watch how the speed of the capture increases as a result of speeding up the digitizer. So it's a little bit faster than it was before. Remember, we're doing 4 lines of average, but also notice something else. My image is more magnified. When I increase my speed, my zoom automatically kicks in. It's a function of the system. We can't change it. So bear that in mind. If you ever increase the speed of the digitizer, you will also increase the magnification of your image. One feature that's very useful when I'm using a specimen with a fluorophore that quenches or photo bleaches very rapidly is I can select a narrow, long window of resolution. So if I select 1024 by 512 and I go live, I now see on my resultant image a narrow window of high resolution. This makes it easy for me to reposition my image using the XY stage, and so the refresh rate is a little bit faster. I can also customize the size of my window. If I click stop and I come here to the resolution tab and I go to more, I can actually change the size of my window with these slider bars. Select OK, go to live, and now my window is even narrower, so I can position very rapidly with my XY stage, and I can focus very accurately using the salt and pepper shaker.